Last one, or I just didn't know how to do it?
Alright, so we're on number 16. So again, the biggest thing with this is to read the directions on all these sections. Because you have to read the directions in order to know what you're dealing with. Right? So in this case right here, we're dealing with a what? Okay, so automatically then you stop and you start thinking. Obviously, this is easy today because you can look at that sheet that I just handed to you. But this is something that you'll have to do on your own tomorrow. So again, you will have to write some of these down on the test. Okay? Characteristics of a parallelogram. You physically have to write them out. Okay? You cannot use it is a quadrilateral. Okay? You have to use the other ones that are on that sheet. Alright? And I think it says on the test, list 3 of 5. There's actually 6. Well, there'd be actually 7 if you counted the quadrilateral one, but you can't use the quadrilateral one. So there's actually 6, but you have to write down 3 of them. So, opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Both sets of opposite sides are parallel. Diagonals bisect each other. And you could actually say one set of opposite sides are both parallel and congruent. And then you could realistically say, in every single one, you could draw a diagonal and make 2 congruent triangles. We don't talk about that one a whole lot, so, okay? So, but again, the most important part of this is the directions, right? Is the directions. So at number 16, 17, 18, 19, any of those questions that blow your mind? So basically, we're looking at consecutive angles in that one, and then opposite sides. Nothing real complicated, really, in a parallelogram, right? 19 is 115, yes. In 20, find the value of each variable in each parallelogram. So how do this one's kind of difficult just because of where the numbers are, right? Or where the quantities are. Obviously, if it has a little degree symbol, it's got to be an angle, right? And hopefully the ones on the quiz or the test tomorrow are a little bit more self-explanatory where each thing is, right? How am I going to find x?
2x plus 9 equals 4x minus 5.
Just set them equal to each other, right? How do I find y?
4y equals 80.
Does 4y equal 83? No. So how can I find out what y is? 4y plus 83 does what? No.
4y plus 42.
What?
Add all together equal to 360.
Add all of what together?
So degree, so 4y, 42, 23, 83.
Would that work?
No, you have all the angles.
You can do alternate interiors.
Well,
Find the angle.
Say it, Karen?
Those are different triangles.
They're different triangles. So, how about this one? Would you agree that 42 and 23 would make up that angle in the bottom left-hand corner? Okay? And would you agree that if I did that angle right there and subtract it, or added that angle up, and then subtract it from 83, could I find the other piece next to 83? See what I'm saying there? See the little section by 83?
could you, wait, could you
Isn't
just,
that,
Yeah, I can't.
wouldn't 23 be the opposite too, though? Isn't that pretty nice? 4y plus y equals 23.
Isn't it something like this? And then it went this way, right? And then it went this way? This little number was what?
42.
Then?
23.
Okay, so what I'm thinking is, if I added these two together, I could get this entire angle, right? So this entire angle is how much? 65. And so if I knew that this angle and this angle, they have to add up to what? 180. So if I took 180 minus 65, I should get this whole angle, right? So what's 180 minus 65?
115.
And then 115 minus 83 would get me that little angle. And then this and this would be what? Alternate interior, so they're congruent. So what's 115 minus 83? So 32 should equal, what was this? So what's y? 8. It's a pretty good problem, actually.
So you have
Especially for this review.
add the two small angles like that, which makes 65. Then you have to subtract that from 180.
Because this and this should equal 180, but I don't know that right now.
But then you use that number, subtract 83 from it.
Okay.
Could you do
Makes
alternate?
sense?
Could you just do alternate interior right away and then do 2030 plus y plus 4y equals 180? So then 5y equals 177. Or something like that.
I can't see this yet.
17, where are you getting 177?
This way. I think it's saying like 4y.
157.
You wouldn't get the same answer.
Go try it. 21. Can I do that one?
Yeah. 2x plus 41 equals 115.
Again, the key to this whole thing is what? That they tell you it's a parallelogram. If they don't tell you it's a parallelogram, I can't do any of that stuff that we just went over. Agreed? Okay. Let's go over to 26. Yeah, just another version of it, but 26 is basically the same thing. I guess they never show you this, and I can't remember if it's on the quiz or the test tomorrow. Remember, if I have an angle here and an angle here, obviously they're across from each other, but if I have an X here and a Y here, they're still equal to each other, but then I gotta automatically, when I have an X and a Y and a problem, that means I have to do the other one too, and then do a systems of equations. Anytime that I have both variables, I gotta go and do systems of equations. That means what?
Elimination.
Elimination or substitution. Honestly, you could graph them, but you guys probably aren't gonna graph them. Okay? So you can line them up. If you're gonna do elimination, one of my variables has to have the same coefficient, but different signs. Coefficient is what? The number before the variable. If I'm gonna do substitution, I solve for one of my variables and then put it into that other one. Okay? Now again, they don't have one of those on this, so. What about 27?
You just do alternate interior and find y.
How about my x's?
Well, where's the X 26?
Well, I'm guessing they're showing that x plus 4 is right here,
Yeah.
and this is the other one, so what's their relationship? They're equal because the diagonals what to each other? Bisect, because they're congruent. But they bisect, they're not truly congruent. The segments of that diagonal are congruent. That's where we got confused the other day.
Yeah, that's what I mean.
Okay? Good to go with that? So again, notice in 26 and 27, it says find x and y so that the quadrilateral is a parallelogram. That would be those converses of, but realistically, you're using the same things. It's just, we're proving that it is a parallelogram by those second set of theorems. No, I'll have to look. Remind me that if you can. Okay there? So now we go to a rectangle. And so as soon as they say a rectangle, all the things in a parallelogram still apply. Okay? But now, don't say it out loud, and if you can, don't look at that sheet. What's special about a rectangle? Just think about it. Okay, what's special? It's got to have 4 right angles. Diagonals now are congruent, but they also bisect each other. Okay, then all the other things that we said about a parallelogram are still true, right? So it's basically the diagonals are congruent and the 4 right angles.
So this is the one where they make 2 sets of congruent. That's also 6 triangles?
Yes, absolutely. Up and down and left and right would both be exactly right. Okay? So, look, 29 through 33. Can I find GEH if I know FEG? Because both of those added together would be what? 90. Okay? And if HGE, can I find FGE?
Yeah.
Those would be what to each other?
Complementary.
They would be congruent, wouldn't they?
What?
Yeah.
HGE and FGE, sorry.
Yeah.
I was thinking FEG.
Oh.
FEG and HGE would be what to each other? Congruent because of alternate interior angles. So basically, 29 and 30 are the same kind of problem, right? Yeah. FK is 32. Can I find EG?
Yeah.
Double it, right?
Yeah.
But both of them are the same. HEF and EFG have to add up to 180 because both of them are 90. EF and HG are congruent, right? Opposite sides are congruent. Okay? Questions there? Turn the page. Now we get to a rhombus. Okay, so again, don't look at the sheet if you can. What is different about a rhombus, or what's special about a rhombus? Shh. Let everybody think for a second. What's special about a rhombus? Everybody got an answer? And one.
All sides are congruent.
All sides are congruent. Automatically in a rhombus. What else, Gabriel?
You took mine.
Like perpendicular, the bisectors perpendicular to each other.
The what are?
Bisectors
The diagonals are perpendicular, which means in the middle, we got 90-degree angles. So we really have what? 90-degree triangles.
Bisect opposite angles.
And then the last one is they bisect opposite angles.
What about consecutive angles out of 20?
Still, because it's a parallelogram. A rhombus is a parallelogram. So anything that we said for a parallelogram is true about a rhombus. Yes. So the diagonals of a rhombus bisect, are perpendicular, and don't have to be congruent, but they split the angles in half.
So it's everything that is a parallelogram and a
Yes. Okay. What's special about a square then?
it's basically combining a rectangle and a rhombus.
Everything is
As long as you, say all the characteristics of a square and a rhombus.
Put that on the test.
You could, if that's a question, yes. But that's not a question. As that sense.
Yeah.
You have to know all that stuff, but
Oh.
you don't have to write it out specifically. Okay? So, again, we read the directions. It says ABCD is a rhombus. So, even though that they don't have it, the first thing I would do in this is put my little slashes in there. And then I would go at E, I'd put a box. And then I would show myself. So again, our A, here's a question, don't say it out loud. Is AC and DB congruent? Why? Because of squish. A rhombus isn't necessarily a rectangle. Right? So my diagonals aren't necessarily congruent, but they still bisect.
And they're perpendicular.
Okay? And they're perpendicular. So really I have a right triangle in there, right? So 34. How do I find AE with the given information? I'm going to do Pythagorean theorem. Sounds good. Remember, in Pythagorean theorem, my C always has to be what? The hypotenuse, which comes from opposite of the 90-degree angle, and it's the number that's by itself, right? How do I find 35? Angle BDA.
It's congruent to ABD,
It's congruent because why?
so it's an isosceles triangle.
Okay? Or opposite or alternate interior angles, right? 36, how do I find CE?
They tell you this one.
It's, oh,
Same thing as 34, right?
yeah.
Okay, or I do Pythagorean theorem again. So if I go down to 39 and 40, how do I know, or what am I going to use to prove that things are what they are on a coordinate plane? Slope, probably, or the distance formula.
Or triangle.
Draw my triangles.
Midpoint.
You could use the midpoint theorem, maybe. Okay. Remember, the other way of always thinking about this is I can always do the things with the diagonals, as long as I can remember the diagonals. Okay? So again, hey, when you do this problem right here, some of you got points taken off on the quiz for just drawing the parallelogram on the graph. Okay? Just because you draw it on there, you got to show that you did some kind of math to it. Meaning you counted it and made the triangles or whatever. But you can't just draw it and say, yes, it is. And you got to show me that you did something to it. All right? Because otherwise, basically, you're taking and flipping a quarter. All right? Is it?
Yes.
Ooh, great math. Guys. Okay. Do we need to do 39 or 40? Anybody need to see one of those? All right, so, again, don't say anything out loud. What makes a trapezoid a trapezoid? Now we only have what? One set of parallel lines. Okay, what else?
Diagonals are congruent.
The diagonals are congruent again.
Just the normal trapezoid.
Any trapezoid.
So an isosceles one.
Yep.
These ones. The legs are congruent.
In an isosceles trapezoid, the legs are congruent. And my sets of base angles. Right? And then we bring in the mid segment again, right? Remember the mid segment, ladies and gentlemen? Oh, this is the other thing. I don't know what some of you were drawing, and I don't know if it was this class or the other class. Okay? But when they say that this is A, B, C, D, you realistically need to go in that order. You can't say A, B, C, D. Okay? Now, in a trapezoid, in the question that we had on the quiz, it really didn't make a difference if you flip-flop these, so I didn't count it wrong. But some of you, I don't know what you were drawing, honestly. It looked nothing like what we talked about as a trapezoid. Okay? So, make sure that you put your letters in order, and it doesn't matter where you start. You could have started, but I think that one said something about AB was parallel to DC, for instance. Okay, so remember, this has to be parallel, so you got to write it that way. Okay, and then my mid segment is this segment right here. And basically, to find this, I'm going to use that formula, right? M equals 1/2 B1 plus B2. Again, B1's the top, B2's the bottom. We'll get into this more when we do areas and stuff. This couple chapters down the line. But, okay. Anything else about a trapezoid that was special? I don't think so. So what's special about a kite?
It's got consecutive sides.
Two sets of consecutive sides are congruent.
The angle connected.
The angle between the two sets
The diagonals are perpendicular.
are equal. The other two don't have to be. And then my diagonals are what? Perpendicular. So again, anytime that they tell you that the diagonals are perpendicular, you're probably going to have to do Pythagorean theorem somewhere. Or there's a possibility of using the Pythagorean theorem. Okay? So, on 41, if they say GH, or find GH from this, can I do that?
Yeah.
Now I'm going to do Pythagorean theorem. On 42, if they say angle Z is what we want to find, can I find that?
Yeah.
Because still, they're consecutive interior angles, aren't they? Because of the perpendicular side. Okay? Is this in number 42, is that an isosceles trapezoid? Because of the numbers, right? You don't have to necessarily put the slashes if they give you the numbers. Okay? Alright, questions here? Again, if you don't want this sheet, hand it back in. Or bring it, or leave it on the book as you leave. I don't care if you take it.